Alright, with today's session, so we're doing 7H. We're still doing integration, uh, but we're gonna look at a particular technique to anti-differentiate. The You probably will see that next the following year at uni. It's The technique is called integration by parts. Now, in year 12 this year, you're not expected to integrate any function using integration by part. You will always be guided in a worded question with multiple parts. The first part will tell you they will give you a weird function and they will ask you to differentiate, so to find the derivative. And once you differentiate, that derivative will have one term can be, you will have to go backwards by using the resulting derivative. Okay. So by starting this, we'll go through two examples. Okay. Uh, so here, the way you will do an integration by part is when you end up. This one is not integration by part. It's just a technique. So here, you have a function. So it's inverse of sine plus x times square root of 1 minus x squared. Now, the interesting part with part B is to find the antiderivative of that function. Now, the way that function is, there is no way for you to anti-differentiate. You do not know any function. Now, you know some technique. You might know, you might try to do a substitution, but you'll find out that if you do a substitution, let's say you have a function like this, what substitution could you use? Anyone? Alright, now let me rephrase that. When you have an integral, when I ask for a substitution, is not a specific value. Is what I want is you have a function in terms of x. What you want to is to create an intermediate function in terms of x to actually simplify your kind of that's kind of complicated function. No? Anyone? Okay, me, I will have a first attempt, and I know it's not going to work, but when I see a function like this, a good idea would be, let's say I want to get rid of the square root, and I see 1 minus x squared. I'm thinking about a trigonometric identity, so you know that cos squared plus sine squared equals 1. What I would use is something like x equals either cos of u or sine of u, and I would substitute in that. When you do that, you might be able to get rid of the square root. Okay, so that could be a potential substitution, but it will not work in this situation. Okay, so using part A, what you need to do is differentiate that. Do you remember the derivative of inverse of sine? So it's probably fairly long to type, but you can speak up. No, not exactly. You're using a reciprocal. This is an inverse circular function. Now, if you don't remember, it's negative 1 over square root of 1 minus x squared. Okay? And how do you differentiate this bit? What rule would you use? thinking about moving the chat over here somewhere. Uh, Hang on, where did we start? Angelo. Yes, so this one, yes, it's a polynomial function to the power of a half. Now, what I was going for the first obvious. It's not obvious, but just one of the first steps. It's x times. So it's a product rule here. You obviously turn the square root to the power of 1/2. Also, something you will have to add because it's 1 minus x squared. You will have to use the chain rule as well. Okay, so product rule, a polynomial to the power of a half, and here inside is a function of a function, so you will also have to use a chain rule. So derivative, that inverse of sine, oops, I was wrong by the sign, it's not -1, it's just a +1. So it's going to be 1 over square root of 1 minus x squared. Okay, so that one we'll leave it on the side. Here we apply a product rule, so this is, you differentiate the x, that becomes a 1, so that gives you your first term. The second term will be the x times, you differentiate that by using the chain rule, so the derivative of that is negative 2x times the square root, that's a half, so that gives you a negative x. And it's it's a power of a half, you minus 1, that gives you negative a half, so you end up with the denominator of a square root. Okay, then what we do is we regroup that as one fraction, so it's a sum of two fractions, so a common denominator is that one, so that comes up with that numerator with the that common denominator, which is the same as the first term, so we can regroup that. We simplify by it's the same expression, the power is just 1/2. Okay, so that derivative is equal to 2 square root of 1 minus x squared. Okay, now if you look at part B, it's kind of looking very similar. So that derivative, I'm going to call it y prime, or I could rewrite dy over dx. Okay, and to make that kind of similar to this one is, if I put an integral here on the right hand side, I can also do the same on the left. Now, what is the integral of a derivative in terms of x? I should have specified that. So again, the question for that left hand side, what's the integral of dy over dx in terms of dx? No? No one? So, alright, so the left hand side, that integral in terms of the derivative, they're actually inverse functions. So when you differentiate, you go from your function f to the derivative, so that's f prime. When you anti-differentiate, you go backwards. So if I do the inverse, I'm going back to my original function f. So I differentiate y, I anti-differentiate. What it means, I'm going backwards, is actually equal to y. And that y is my original function here. It's all of that. That's my y. Okay? So by doing the derivative of that complex function, it's not something you'll be able to guess from looking at this integral, but that will be given to you. You differentiate, and that is very similar to that one. So you will have to take the factor 2 out, and you will have to specify the boundaries as well. So let's do that. So we use part A. That's the that was the right hand side of the equation. That is your y function. Don't forget you have a plus constant. So you do the integral. Now because we specify the boundaries, the limit, we anti-differentiate from 0 to a half. I don't care about the constant. What I'm going to do is around my function y, I'm going to put square brackets, and I'm going to specify the boundaries from 0 to a half. Okay? That coefficient 2 move outside the integral, and we transpose by dividing by 2 on the right hand side. And now when you have your square brackets from 0 to a half, we can write it as a difference. So your function y, we substitute the value a half for the upper limit minus the same function, and we substitute x by 0. So this bit is y of a half. Take away y and you substitute x by 0. Okay? So using your exact value, you need to be able to simplify that. That gives you that amount. You expand it, that's pi on 12 equals plus root 3 over 8, and that gives you your integral. So that part B can only be solved by that hint given to you in part A. Okay? Yep. Do we include C in it? No, that's the reason. What's important? So when you anti-differentiate, you have your integral, and you don't specify the boundary. The general answer will have a plus C. When you calculate a fixed integral from a given interval, you don't need to worry about a plus C, because what happens is you specify the boundaries, and that makes that C obsolete. You don't need it anymore. You actually narrow it down to a specific function. The plus C tells you when you anti-differentiate a function, you get a family of functions that has a vertical translation, but you don't know where it is. But by selecting the boundaries, you narrow it down. So you don't need the plus C anymore. Okay? So your final answer will be a numerical answer without a variable C. Okay? Alright. Last example. So part A, you have a product. It's x times e to the power 2x, and that's integration by part. What happens is, by using a derivative, the derivative of x, which is one of the factors, when you differentiate a linear function, it becomes constant. So you reduce the degree to bring it back to a constant, and by doing that, when you do you differentiate and you do a product rule, that product you differentiate, one of the term will have a 1 times in front. The x has been differentiated, it becomes a 1. So now we end up with exponential of 2x. Okay? And that second factor is what we're gonna use, what we're looking for in part B. That's coming from here. Okay? So when we all that, if I apply the integral, so I have that integral, that's what I want to figure it out. That first term, when you do the integral, because we got rid of the x factor, you should be able to anti-differentiate that. Okay? And that integral of a derivative being inverse functions, they cancel out, and that just simplified to y. Okay? Now, Angelo, you mentioned the plus c, the constant. Notice that integral doesn't have any boundaries, so your final answer must include a plus c. Okay? So you have your product. We can move on to part B. With part B, I have too much stuff. Let me drop that out, because it's exactly what I just wrote. Okay. Alright, so we look at part A. So if I go back, That's the left hand side. That represents this side. That's the right hand side. Okay, and that will be shifted to the right hand side. So that will become that x e of 2x. That's the integral of the derivative of x. Okay, and we need to add a constant. And that right hand side of part A, which now is the left hand side, is the integral of e of 2x. So it's actually a bracket here. It's the all of that is the integral. Now we're going to split it into two integrals, and we're going to transpose that e of 2x to the right hand side. So that's why it becomes a negative. That is you anti-differentiate, that becomes, there's a 2 here, so you need to factorize a half when you anti-differentiate. That will create a new constant, but those two constants we can combine it as a new constant. That's why they call it C later on. Okay, so add your two constants C1 and C2. Fact, on the left hand, going back to the left hand side, we need to keep in mind the factor to outside. So we're going to divide by 2. That's going to be a half here. We regroup the constant together, and that's your function over here with a new constant. So the integral of part B now is equal to, after you expand, so what it did is they factorize a quarter. So because they have a quarter here, they need to put a 2 in front here. That 2, they factorize exponential of 2x for both terms. So you have a 2x minus 1 here, and that C1 plus C2 over 2 is simplified to 1 constant. Okay? So just be mindful, just part A, just be
तुमचं का
vigilant
म्हणत
into
ठेवलंय
your
कारण आमचा
derivative
क्लास
of
आधी
the
होता ना फर्स्ट हाफ मध्ये
yes,
सेकंड हाफ मध्ये 12 शिकतो.
okay. So with the derivative, use the product rule. Be careful also, you might have to use the chain rule for one of the factor function. Okay, so e of 2x, it's use a chain rule. Okay, and then you need to isolate the integral that you after by doing a little bit of transposition. Okay, I think that's the end. Do I want to start 8? It's not too long. Let me move. No, that's it. Alright, there's a question. Hang on. You know how you separate it into two parts. So let me go back to that. So the left hand side, yes, we separate into two parts. Yes. So this part will be integral of e of 2x. When you transpose that on the other side, that becomes a negative. I guess you could, but the idea is we want to keep x e of 2x on the left hand side, which is what we after from part B. Alright, so that's the end of chapter 7. I can stop my recording.